Hello, children. Welcome to online classes Electrochemistry. We are going to discuss some important questions related to CET and Comet K. We are going to have discussion on three topics: electrochemistry, solutions, and surface chemistry. The first question: molar conductivity of a solution is given 1.26 into 10 power 2 ohm inverse centimeter square mole inverse. Its molarity is 0.01 molar. Molarity is given. Specific conductivity will be how much? The question is, what is the specific conductivity of the solution? So to determine this particular one, we need to go with the formula of molar conductance. Coming to this, it is given the data. Lambda m is given 1.26 into 10 power 2. Molarity is given 0.01 molar, and they are asking to find K value is how much. We know the formula. Lambda m is equals to K into 1000 by molarity. From this I can write K is equals to lambda m into molarity by 1000, which can be written as 1.26 into 10 power 2 into molarity is 10 power minus 2 by 10 power 3. 10 power 2 10 power minus 2 gets cancelled, so 1.26 into 10 power minus 3. The units of this one comes to be Simon centimeter inverse or ohm inverse centimeter inverse. I hope this answer is in which option? We'll see 1.26 into 10 power minus 3. This is in the option B, so the answer should be B. Correct. So this is how we'll solve this particular question, the first one. Coming to the second question, the conductivity of 0.0001. I think there is a mistake. When 0 will remove this. So just correct this question. 0.001 molar acetic acid is given 5 into 10 power minus 5. Simon centimeter inverse. Lambda naught is 390.5 Simon mole inverse. Now then calculate the value of dissociation constant of acetic acid would be. So the dissociation constant of acetic acid is how much? So they are asking you to find Ka value. So to get Ka value, we need the terms are Ka. To get alpha, we need to know lambda, we need to know. Each are interrelated terms. These are interrelated terms. So to get Ka, first we need to find this. To get alpha, we need to find this. So how do we find this particular one? We'll see in this particular term. First, what is the formula for alpha? Lambda c by lambda infinity. This is going to be our formula. What is the formula for lambda c? Is K into 1000 by molarity. This is going to be our formula, where K is given to us in this particular one. The K value is given is 5 into 10 power minus 5, and M value is given 10 power minus 3. Sorry, 10 power plus 3 here. 10 power plus 3 by 10 power minus 3 is given over as molarity. So lambda will be equals to 5 into 10 power minus 5 into 10 power 6, which is equals to 50. You will be getting 50 Simon centimeter square mole inverse. Coming to this particular one, we have lambda c. Also they have given lambda infinity to us, that is 390.5 Simon centimeter square mole inverse is given to us. So using this alpha, we can find alpha will be equals to lambda at concentration C2, lambda at infinite dilution, which can be written as 50 by 390.5. Approximately you will be getting a rough answer 0.128, somewhere around this you will be getting an answer. And this particular one, now we are going to use this alpha to find Ka. Ka is equals to C alpha square. Substituting this particular one, concentration is 10 power minus 3 into alpha square 0.128 whole square. You'll be getting an answer approximately 12 13 13 169. So around the answers around 16 17 into 10 power minus 6, somewhere you will be getting an answer in this particular one, which is approximately, I can take an approximate value, you will be getting around 17 into 10 power minus 6 it will be around this particular range. Which option is there for us in this particular range will be your answer. So it is close to that is your C option, option with 10 power minus 6. So let us see the answer for this particular one will be, what will be the answer? Yes, the answer is C. C is the answer, 18.78 into 10 power minus 6. So this is our second question with a small correction which we have done here, that is 10 power minus 3 molar. If you take 10 power minus 4, alpha will be getting greater than 1. That cannot be possible. That's why we corrected this particular one. So coming to the next question, question number 3. The limiting molar conductances of NaCl, KBr and KCl are given, and they are asking you lambda naught value for NaBr. NaBr is how much? I think this is the concept comes from Kohlrausch law, the application of Kohlrausch law. So for this particular one, we will be taking this concept in such a way going forward. Lambda naught value for NaBr they are asking you, and they have given you lambda naught NaCl, they have given you lambda naught KBr, they have given you lambda naught KCl. According to our concept, when I have explained in the concept, I said whichever is having a common ion that should be added. Na is a part of NaBr, so it is positive. Br is a part of NaBr, so this is also positive. But KCl, none of these elements are part of NaBr, so this is taken as negative. Now substitute the data which is given to this: 126 plus 152 minus 150, which is equals to 2 plus 126, 128 centimeter square mole inverse. So which option is 128? That is going to be our answer. So moving to, so the answer for this particular one is answer option A. So the answer should be option A. Let us see. Yes, answer is A. So 128 is our answer. I think understood everyone. Now coming to the next question. Let us move to the next question. 1 Faraday charge was passed through electrolytic cell in series of Ag plus, Ni2 plus, Cr3 plus. Then what is the amount of the substances deposited? 1 Faraday is equals to 1 equivalent is 1 mole of electrons. So if you get 1 mole of electrons, 1 mole of electrons are given to Ag plus, given to Ni2 plus, given to Cr3 plus. You get 1 mole Ag, you get 1 by 2 mole Ni, you get 1 by 3 mole of chromium. So correspondingly you will have 108 over here. This will be 1 by 2 times of 1 mole of nickel is 59 given in the question, 1 by 3 of 52. So the answer should be 108. 108 is in everywhere 108 is there, but half of 59, 29.5 is here. 1 by 3 of 52, 17.3 is correct. So the answer should be A. So let us see the answer. Answer is A. So the answer is correct. We got the option A. Moving to the fifth question now. Electrochemical equivalent of an element is 0.00066735 gram per coulomb. This is very important. Gram per coulomb is given. Its equivalent weight is how much? So how do we calculate? 96,500 coulomb is equivalent to equivalent weight grams of a substance. Then 1 coulomb is equivalent to 0.00066735 grams. If 1 gram is this many grams, then 96,500 coulombs is equal to how many? That always will be equal to equivalent weight. So to get equivalent weight, multiply that with 96,500. We are going to do that. So we have the data is this one, 0.00066735 into 96,500. So how much is an answer? In examination, what we do? We have two methodologies. Exact calculation we do, otherwise approximation. Let us see the approximation over here. What will be the approximation of this? If you assume 96,500 to be 10 power 5, 1, 2, 3, 4, 5, so 10 power 5 multiplied with 0.000673. If I do moving to 10 power 5, the answer will come is 67.35. So answer comes is 67.35. If you have increased the value from 96,500 to 10,000, then you will be getting an answer 67.35. But it is 96,500 is less than that. So your answer will be less than 67.35. In the option whichever is less than that particular one, the answer will be that one. Let us see the options given to us. 67.35, 65. This cannot be possible. This cannot be possible at all. So the answer close to 67.35 and less than that is option A. So the answer for us will be option A. So easy way to calculate this particular one. Let us easy understand the approximation methods also. Moving to the sixth question. When aqueous solution of copper sulphate is electrolyzed using copper electrodes. Please try to understand, this is copper, this is copper. Any electrolyte in its own solution, we call those electrodes are called as active electrode. Active electrodes, in active electrodes, no role of anions, no role of anions in the electrolysis process. So no role of anions in the electrolysis process, that is going to be your active electrodes. No roles of anions in the electrolysis process. So first thing, if you have an anion, imagine, remove that particular one from your options first. So no role of anions. Second, they are asking you the reaction that takes place at anode. We know an ox, red cat. This is our simple methodology. Oxidation should take place at a anode. Oxidation is loss of electrons. So this is gain of electrons. Here this is gain of electron. This is gain of electron, so this should be removed. This is also gain of electron, this is removed. This is the loss of electron, so the option left out should be answer D. So the answer will be D. I hope everyone has understood this particular one. This is active electrode concept to be understood in this particular one. Moving to seventh question. During electrolysis of fused, the word you need to take here, it is not aqueous. Aqueous is different. Fused is different. Fused sodium chloride, anodic reaction. In fused state, cation directly goes to cathode, anion directly goes to anode. So chloride ion goes to anode. Cl minus ion will convert into Cl2. So this will be observed in the case of this process is loss of electrons. So this is oxidation. So oxidation at anode, where you have this particular one, oxidation of chloride ions, option A. So the answer will be A in this particular one. So the answer is A, oxidation of chloride ions. Moving to question number 8. Which of the following electrolytic solutions have least specific conductance? Specific conductance, K is taken as the condition. K is directly proportional to concentration. So if concentration is high, K will be high. Among all the options which are provided, the highest concentration is an option A. So we can go the highest, option A has highest K value. And the question is about least K value. Least K value will be not in option A, will be in option B, which will have the least K value. So the answer should be option B. So the answer should be option B. Yes, that's the condition. So understood? So least K value for least concentration. That's the condition. Moving to the next question. Question number 9. The half cell reactions with its standard reduction potentials are given. You have to identify which will occur. Understand the questions every time when you read. Please try to read it carefully. Which will occur is the question. So here you see this value is negative, this value is positive. Before you go to conclusion, check whether it is reduction potential. Yes, this is reduction potential. Yes, this is reduction potential. Now you go with second. Negative, positive. Negative is always anode and positive is always cathode. This is our condition. So negative, positive, if there are one negative, one positive, always negative should be taken as anode, positive should be taken as cathode. An ox, red cat. Come to this particular one. So anode means oxidation. So Pb corresponds to negative. So Pb should undergo oxidation. Ag should undergo reduction. Where do we see? Here Pb is undergoing reduction, so this is wrong. Here there is no Pb at all, so this is wrong. Here Pb is undergoing reduction, this is wrong. So the only option left out with that is option D. So the answer for us will be option D. I hope I am clear. So first you check the reduction potentials correctly given. Electron should be on the left hand side, then negative, positive, anode, cathode, then the reaction. Question number 10. Now SRP values are given for copper, mercury, zinc, 0.3485, 0. minus 0.76. The wrong statement, underline that. The wrong statement, not the correct one, we have to say. So now what is the wrong? Let us say first we'll arrange them in the order more negative to positive. From negative to positive, let us arrange. So first one will be zinc, followed by you'll have the next value will be corresponds to copper, next comes is your mercury. So always whoever comes first can displace remaining two. So zinc can oxidize, zinc can reduce copper and mercury. So this is the correct statement. Yes, this is the correct statement. Zinc can reduce copper. Yes, this is the correct statement. Zinc can reduce mercury. Yes, this is correct statement. But can mercury can reduce copper, zinc or copper? No. So this is your wrong statement. We want the wrong statement only. So this is your answer. So this becomes your answer. The wrong statement becomes your answer. So the answer for us will be, which one will be the answer now? The answer is option C, because zinc cannot reduce, mercury cannot reduce the zinc ions. That is the condition. Moving to the 11th question, based on the data, correct order of reducing power. Reducing power means which can undergo oxidation readily. Which can undergo oxidation readily, that is having more reducing power, opposite to the nature, reducing agent, oxidation. So now when you take in this particular one, arrange them from negative to positive. Negative to positive if you arrange, we'll have aluminum coming first, then comes your iron, then comes your bromine. So which is having more reducing power? Aluminum, then comes iron and bromine. So highest is for aluminum, where you have aluminum is having highest here. Iron, this is wrong. In this case iron is having highest. In this case bromine, this is wrong. In this case you have iron having highest, this is also wrong. So the option left with aluminum having highest reducing power is an option A. So let us answer is option A. I think everyone understood this now. So let's go to the next question, 12th question. And the 12th question, the standard electrode potentials of 4 elements are given A, B, C, D, and the highest chemical activity will be exhibited by. Chemical activity is directly proportional to negative E naught value or inversely proportional to E value. You say more the negative value, more chemical reactivity, more the positive value, less is the chemical activity of that metals, if we are taking into consideration. So if you see in these, these are negative and this is positive. Let us go for positive is already eliminated, D is already been eliminated from the list. Among A, B, C, which is having more negative, 2.65. So what will be the answer for us? A will be our answer. So the answer for us will be A. So because of the highest negative, that will have more reactivity. Coming to 13th question, spontaneity of a cell. If you say spontaneous, according to thermodynamics, delta G negative is spontaneous. We know delta G is equals to NFE minus NFE. Minus NFE, if you take, if delta G is negative, then E should be positive. So delta G less than 0, E greater than 0. This is the condition for spontaneity. We have this is not correct, this is not correct, this is not correct. So this is the only option where you can get the answer. So the option will be answer D. So the answer for us is option D, the only one which will satisfy this. Next, coming to the 14th question, how many faradays of electricity are needed for conversion of MnO4 minus to Mn2 plus? So if I am taking MnO4 minus to Mn2 plus, it is in +7 oxidation state, changing to +2 oxidation state. change is 5 electrons. 5 electrons is equivalent to 5 Faraday. So the number of Faradays is 5 Faraday. So the answer will be option B. So the answer is option B, 5 Faradays. Coming to the 15th question, the EMF of the galvanic cell with electrode potentials of zinc is given and copper is given. What will be this? E cell is equals to E naught is equals to E naught cathode minus E naught anode is our formula, which is 0.34 minus of minus 0.76, which is equals to plus 1.10 volts, which is in option D. So the answer will be option D. So the answer is option D. The case of 15th. Moving to 16th question. You have given three equations of given zinc and copper couple. Which of the following is true? So for this particular one, let us go with the assumption of this E cell value. E cell is equals to E naught cell minus 0.059 by n log QC. So if I am taking is this term is and this term is same for all the three equations. This is same for zinc copper couple in all the three equations given to you. So the only term E cell depends is only on QC. E cell depends on what is the relation? From this I can say E cell is inversely proportional to QC. That means if Q increases, E cell value decreases. So this is going to be our key statement for us now. Now what is QC? QC is equals to concentration of Zn2 plus ion concentration to copper Cu2 plus ion concentration in all the cases. So according to that, if you take Q1 is equals to, if I am taking this particular question, in the question what is Q1 given to us? According to this question, the Q1 will be 1 by 0.1. So if I am taking this particular one, Q1 is 1 by 0.1 and Q2 is equals to 1 by 1, Q3 is equals to 0.1 by 1. So the concentrations of zinc and copper in all the equations, if you see, so that in this case Q1 will be greater than Q2 will be greater than Q3. That implies answer will be E3 will be greater than E2 will be greater than E1. So let us see where this option comes. In this particular one, you can see Q in this case is 1 by 0.1, Q2 in this case is 1 by 1, Q3 in this case is 0.1 by 1. So from this what we have written, Q1 greater than Q2 greater than Q3. So the answer should become E3 greater than E2 greater than E1, and that is observed in the case of option B. So the answer should be option B. Clear now? Very easy way. That's the difference. Q inversely proportional to E. This is how I have approached. Moving to the next question. Question number 17. The standard EMF of the galvanic cell is 3 moles of electrons in redox is 0.59 and the equilibrium constant for the reaction. So the formula for this E naught cell is equals to 0.059 by n log Kc. This is the formula. From this I can write log Kc is equals to n is given as 3, E naught cell is given 0.59 by 0.059. So this is nearly 10 times, that is equals to 30. Log Kc is 30, that implies Kc will be equals to 10 power 30. If log Kc is 30, it should be 10 power 30. So the option should be option D. So the answer is option D, 10 power 30. So log K is equals to 30. We got this particular value. So we have the option K is equals to 10 power 30. So that means the answer should be equals to option D, 10 power 30. Moving to the 18th question now, the standard electrode potential for the half cell reactions. They have given two cell reactions. This is reduction potential, this is reduction potentials. Yes. Now you have the two values over here. Now tell me which is more negative. This is more negative. This is less negative. More negative goes for anode, less negative goes for cathode. Now E naught cell is equals to E naught cathode minus E naught anode. So minus 0.44 plus 0.76. This should be giving you a positive value 0.32 volts. 0.32 a positive. There is two 0.32, but the positive value we wanted. So the answer will be a positive value of plus 0.32. That is going to be our answer. Now moving to the 19th question. Hydrogen electrode in the is dipped in the solution where pH it cannot be that much huge as per the options. That's a slight correction here. Let us take pH is equals to 3. If pH is 3 at 25 degrees centigrade, then the potential in V would be expressed as, we have the formula for hydrogen electrode. E naught hydrogen electrode is equals to minus 0.059 into pH is the formula. So if you write minus 0.059, if you take 3, this will be equals to minus 3 nines are 27, 3 5 15, 17, 1 0 point. So minus 0.177. So the answer for this should be option B. Option B. So a slight correction is there. pH should be taken 3 because options no option will match for that. So I am taking the small correction over here. Okay. So moving to the next question. So the next question is aluminum displaces hydrogen from dilute HCl where silver does not. That means aluminum is a negative and silver will have positive E naught values. That is the point we can take from this line. The EMF of the cell prepared by combining aluminum and silver is 1.23, and the reduction potential of silver electrode is given 0.8, and the reduction potential of aluminum will be how much? We know if this becomes negative, this becomes anode and this becomes cathode. So that is our hint in the question. So how to take the hints? This is how we need to take the hint in the question. Just understand. So now your E naught cell will be equals to E naught cathode. E naught cathode minus E naught anode. Just don't hesitate to write anything. So your overall value is given 1.23. This will be equals to E naught cathode is given 0.8 minus E naught anode. We don't know aluminum. So from this aluminum, if you want to get E naught aluminum, this will be equals to 0.8 minus 1.23. So a negative value is going to be your answer. How much will be this one? Approximately 0.43. So the option should be option D. So that's correct. Option D is our answer. So very easy questions. Just focus on the hint given in the question. You can answer the questions very easily. Okay. So now next question 21. When a solution of weak electrolyte is diluted. So effect of dilution is inversely proportional to K. So if your dilution increases, K value decreases. Whether it is weak or strong, it does not matter, but it is directly proportional to lambda. Lambda increases. So this is our conditions. If we can remember this way, we can answer the question. So and dilution specific conductance should decrease, equivalent conductance should increase. So the answer should be option D. So let us check. Yes, it is option D. That is our question. Next, moving to the question for 22nd question. And in the electrolysis of dilute H2SO4 using platinum electrodes, when you are dilute H2SO4, if you take 2H2SO4 is undergoing cleavage, it gives you 2H plus plus, or I can take H2SO4, 2H plus plus SO4, 2 minus. So you are having a cation is H plus, anion is SO4, 2 minus. Now they are asking you about cathode and anode. Cathode, hydrogen will go to the cathode and hydrogen gas will come. So this is wrong. And anode, if you talk about anode, SO4 2 minus will be there and OH minus from water will be there. In these two, SO4 cannot go, OH minus will go. Following the order, you have this particular one, F minus, SO4 2 minus, NO3 minus, OH minus, Cl minus, Br minus, I minus, and CO3 2 minus. This is the order. Whichever is coming at the last, that will go to the respective electrode very fastly. Your SO4 2 minus is here and OH minus. This cannot go, this can go. So OH minus goes to the electrode, and from OH minus, who is going to release? Oxygen gas is going to release. So the answer should be option C. Let us see an answer. Yes, option C is the correct answer. Moving to the next one, 1.12 liters of hydrogen is obtained on flowing a current for 965 seconds in a solution. The value of current is, if you take this particular one, how to answer this particular question? If you see 1.11.2 liters of hydrogen is equivalent to one equivalent which is equal to 1 Faraday, 1 equivalent 1 Faraday. 1.12 liters of hydrogen will become now equals to, then this will become equals to how much? This will be equals to 0.1 equivalent, which is equals to 0.1 Faraday. If you take it is 0.1 Faraday, now your answer will be corresponding to this. What is our question? Coming to this question, if 1.12 liters of hydrogen is obtained and flowing a current of 965 seconds. So coming to this particular one, moving to 965 seconds. Now your number of equivalents is equals to I into T by 96,500. This is our formula. So 0.1 is equals to I is 965 into I, we wanted the amperes, by 96500. So this is 100 times. So I will be equals to, when you take this particular one, I will be equals to 10 amperes. This is going to be your answer, 10 amperes. So the answer should be 10 amperes, which will be the answer for us. So in this, the answer is 10 amperes. 10 amperes is your correct answer. Okay, coming to the next question, question number 24. The standard reduction potential of Cu2 plus to Cu2 plus to Cu plus is given. Standard potential for Cu plus to Cu is how much is the question. So for this type of questions, let us go with an approximation like this. Cu will be converting to Cu plus, will be converting into Cu2 plus. If I am taking this particular one, this Cu will be changing to Cu2 plus in this direction. And what was given in the question, let us see. Cu2 plus to Cu is given 0.337. Cu2 plus to Cu plus is given 0.153. Cu2 plus to Cu, where we have this particular value given to us. Cu, okay, let us come to Cu2 plus to Cu. This is given 0.335, correct? Yeah, 337. And the second, what is given in the other one? And Cu2 plus to Cu plus is 0.153. 0.153. So this is going to be the next one, Cu 0.153. If I have this with me now, what is the value of this is the question. Now here N1 is 1, here N2 is 1, here N3 is 2. The formula for us, N3E3 is equals to N1E1 plus N2E2. This is the formula. So if I want N1E1, E1 is equals to N3E3 minus N2E2 by N1, which is equals to N3E3 is 2 into 0.337 minus 0.153. This is going to be our answer, and an answer approximately comes to be 0.5, close to 0.5. So which option is there to that particular one close to is option C. So the answer should be option C. This is our answer. 24th question we have completed. Moving to 25, the platinum hydrogen electrode. This is an example of concentration cells. Concentration cells are those cells whose E0 cell value will be equal to 0. Both electrodes are made of same type of electrodes. Both the half cells have same electrode. They are called concentration cells. What is the formula for concentration cells? E cell is equals to 0. Or we can say 0.059 by n log of C2 by C1 in concentrations, or 0.059 by n log of P1 by P2 in terms of pressures. This is the standard formula where E cell is given in terms of concentration C2 by C1. In terms of pressure, it should be P1 by P2. So in the options, P1 by P2 is here, P1 by P2 is here. But in the reaction, if you see what is the N value corresponding to that, N value is 2 in this case, because 2H plus gives rise to H2. N value is 2 electrons. So N is 2. It is not here, it is here. So the answer should be option B. So the answer should be option B in this case. Coming to the next, the question in electrochemistry, which reaction is not feasible? Not feasible, let us write for the halogens given immediately. Make sure this way of arrangement, fluorine, bromine, iodine. The top one can displace bottom one, but bottom one cannot displace the top one. That's the point. So bromine can displace iodine, correct? Iodine can displace bromine. Can it be possible? No. Chlorine can displace bromine, correct? Fluorine can displace oxygen, correct? So the answer which is not possible is only option B in this case. So the answer should be option B. The reason is explained, I hope. Now moving to the questions. Now we are moving into solutions topic. Amount of solute dissolved in 180 grams of water to reduce the vapor pressure to 4/5 of pure water. 4 by 5 times of pure water. Let us see this. P naught minus P by P naught is equals to X solute. X solute we can write is W2 by M2 into M1 by W1. In this P naught minus P, what is given? P is equals to 4 by 5 P naught they have mentioned. So P naught minus P will become 1 minus 4 by 5 of P naught. So delta P by P naught becomes, it is 1 by 5, which is equals to 0.2. So this is 0.2, which is equals to weight, which is given in the question. We have to find the weight. So what is going to be W2, where this is 60 into this is given as 18 molecular weight of water. This is corresponding to water. So 18 by 180. This is 10 times. So W2 is equals to 120 grams. So the answer should be 120 grams. So the answer is 120 grams. Moving to 28th question now. So 28th question. Osmotic pressure of a solution of 3.42 grams of sugar in 500 ml of solution. So what is the formula for osmotic pressure? Pi is equals to W by M into RT by V. This is your formula, where W is given 3.42 by 342 into R. I can take approximately the value of R is 1 by 12. T is given 300 by V is going to be 0.5 liters. Approximately, if you see, this is going to be cancelled, and so 4 times 4 into 0.5 is 1 by 2, 0.5, close to 0.5 atmosphere. Which option is there? That is my answer. So option B. So the option B is my answer. Coming to 29th question. If observed and theoretical molecular mass of KCl is this one and this much, degree of dissociation of KCl. The hint in this particular question is dissociation is the word used. For dissociation, first I value will be greater than 1. Remember this one. Now I is ratio of two molecular masses. If we take which one by which one, you will get greater than 1. 74.5 by 38.75. If you take, we'll get greater than 1. So this will be coming an answer as approximately you will be getting 70. What is this? 74.5 by this value will be equals to 1.92. Approximately, I think you will get calculator video 1.92. And now we know I is equals to alpha is equals to I minus 1 by N minus 1 is the formula. I is 1.92 minus 1. Number of moles KCl will give you K plus Cl minus how many molecules it is splitting? 2 minus 1. So the answer will be 0.92. So the percentage will be how much? 92% is going to be option A, 92%. Now moving to question number 30. In the question number 30, if a solution follows Raoult's law, it should be an ideal solution if it follows Raoult's law. So that means that should have same pressure. It should not be greater, it should not be less, it should not have any difference, it should have remain same, the forces remain same, enthalpy should be zero, volume should be zero. So the answer should be option C, and that is your definition of ideal solutions. Coming to 31, aqueous solution freezes at this point, elevation in boiling point if Kf is given and Kb is given. So the formula for this is delta Tb by Kb is equals to delta Tf by Kf. Simple formula. So from this, delta Tb is equals to delta Tf is given as 0.186 by Kf is given 1.86 into Kb becomes 0.512. So this will be 0.1 times. So the answer comes 0.0512 and approximate. The answer is option D. So you'll get an answer option D. That is going to be your answer. So coming to the 32nd question. The 32nd question, 12 grams of urea in 1 liter of water, 68.4 grams of sucrose in 1 liter of water. The lowering of vapor pressure in first solution is related to second solution. So if you take urea 12 grams by molecular weight of urea 60, this is your number of moles. If you take sucrose N2 68.4 by 342, this is molecular weight. So N2 will be equals to 0.2 moles. N1 will be equals to 6, 2 times 2 by 10, so 0.2 moles. If you have same number of moles, colligative property depends only on number of particles. So this is colligative property. Lowering of vapor pressure is a colligative property. It depends purely on the number. If the number is same, the property remains same. So the answer is option C, equal to the second solution. So now the answer is option C, the equal to second solution. Coming to this particular one, the 5% solution, that third question is isotonic to 0.877%. The molecular weight of X is. So if you say isotonic, then W1 by M1 is equals to W2 by M2. This is the formula I have given you in the synopsis. So 5 by molecular weight 342 is equals to 0.877 by X. What is the molecular weight we wanted? That will be, so solving this particular one, you will be getting an answer approximately close to 59.98. So 60 approximately to that. So the answer will be option A. So that is your answer. Yes, option A. Simple logic, isotonic formula, apply this. That's it. So moving to the next one. So the next question is elevation in boiling point for 13.44 grams of CuCl2 in 1 kg of water, and CuCl2 is 134.4. So when you take in this the molality, if you calculate molality, that is 13.44 by 134.4 into 1 by 1 kg of water. So what will be this one? 1 by 1, that will be equals to 0.1 molality. Now what is your formula? Delta Tb is equals to I into Kb into molality. Why we are writing I? Because it's an inorganic salt. For inorganic salts, always mention I in your formula. Without this, your answer is incomplete. So this I will be CuCl2 will split into Cu2 plus 2Cl minus. So how many molecules it is splitting into? 3 molecules. So 3 into Kb is 0.52 into 0.1. So approximately 3 into 0.5, 1.5, close to 0.15. The option is C, which is close to that. So the answer will be option C. That's it. Very easy questions. Any question you solve, it does not take much time than this. It's very easy. Just observe the formula, what I'm using, when I'm using I, when I'm not using that. One logic, if you remember, you can answer this question easily. Moving to 35th question. And 35th question is osmotic pressure of 0.1 molar solution of KNO3 and acetic acid. They have given 2 or P1 and P2 respectively. Thus, what is the answer? The only point we need to remember here, the concentration is same. They are all dissociating into same number. So number is same. But what is the condition? Their number is same. Concentrations are same. But the only point you have to remember here is this is a strong electrolyte, this is a weak electrolyte. For strong electrolyte, osmotic pressure is more, weak electrolyte it is less. So what will be the condition? Osmotic pressure of strong electrolyte is greater than weak electrolyte, option A. Logic, just find out this way. So going to 36. So moving to 36, what is the boiling point of water? 98.5. If it is 98.5, what would be the external pressure? We know boiling point is the temperature at which vapor pressure is equals to atmospheric pressure. So if external pressure is 1 atmosphere, it is 100. If it is 100 degrees, it is 76 centimeter of Hg. If this is decreasing, this should also decrease. So what should be the answer for this particular one? Your answer should be less than 76 centimeter of Hg. So the answer for this is option D, less than 76 centimeter of Hg. Moving to 37th question. The 37th question is adsorption is accompanied by, in an adsorption, delta H is less than 0, delta S is less than 0, delta G is less than 0. Spontaneous entropy decreases and exothermic reactions. This is the data we have. Decrease in entropy, correct. Decrease in enthalpy, correct. T into delta S is your delta G is negative, correct. So all are correct in this particular one. So the answer should be option D. Coming to 38. What is 38? Which of the following types of metals forms the most efficient catalyst? Most efficient catalyst, always the variable oxidation state should be the property for catalyst. Variable oxidation states. Who can show variable oxidation states? They can be the effective catalyst, and that is the property of transition. Alkaline earth metals cannot show variable oxidation states. So the answer for this should be option C. So that is 38 one. Now moving to 39. 39th question. Extent of adsorption of gas on a solid depends on. Extent of adsorption of gas on a solid depends on nature of gas. Yes. If your gas is polar, more adsorption. Non-polar, less adsorption. So here polar nature of gas, more adsorption than non-polar. So that also matters. So pressure of the gas, yes, increase in pressure increases the adsorption. Temperature, increase in pressure decreases the adsorption. So inversely proportional to adsorption. So this is where we can say all are correct in this particular case. So all are correct, option D. So moving to the 40, the phenomena of simultaneous absorption and adsorption is called. Simultaneous adsorption and absorption, this is called as removing this, that's simply called as sorption. The word sorption. Both undergoing adsorption and absorption is called sorption. Moving to 41. So what quantity of NaCl is to be added to 200 grams of water in order to prepare 0.1 molar NaCl solution? So molality is equals to number of moles of solute, W2 by molecular weight 2 into 1000 by weight of solvent. So we need to know the quantity. So M2 by molecular weight is equals to, we have NaCl 58.5 into 1000 by 200 is the molecular weight of solvent will be equals to 0.1. From this, if you solve, W will be getting an answer for W will be 1.7. So this will be the option, will be getting 717 grams, close to this particular option. So the answer will be option B. Yes, option B is the right answer to us. Now moving to 42nd question. 42nd question, a solution contains 6 grams of urea in 100 grams of water. The concentration of solution is. So if it is a 6 grams, the concentration, it is the solvent given. Remember, it is solvent mass is given. So I have to express the concentration in terms of molality, not in terms of molarity. So this is going to be eliminated, this is going to be eliminated immediately, since I am going to express the concentration in terms of molality. So the answer M is equals to 6 by 60 into 1000 by 100, which will be equals to 1 molal. So the answer will be 1 molal, which is there in option C. So the answer will be option C. Now moving to the 43rd question. So the 43rd question, the compound whose 0.1 molar solution has maximum osmotic pressure at 25 degrees centigrade is. So osmotic pressure is directly proportional to Van 't Hoff factor when concentration, temperature are constant. It only depends on Van 't Hoff factor. So Van 't Hoff factor for this is equals to 3. Van 't Hoff factor for this is equals to 2. For this it is 1. For this it is 1 because no dissociation, no dissociation. Splits into K plus and Cl minus 2 parts, Ca2 plus and 2Cl minus 3 parts. So you have more composition for CaCl2. So that will be our answer, option A. So moving to 44th question. The 44th question, if alpha is degree of dissociation for Na2SO4, what is Van 't Hoff factor? Van 't Hoff factor is given by 1 plus n minus 1 into alpha, that is equals to, if you split Na2SO4, it will split into 2Na plus SO4 2 minus. So how many ions are coming? 3 ions are coming. So I is 1 plus 3 minus 1 into alpha, that is 1 plus 2 alpha, which is there in option B. So my answer will be option B. Yes. Coming to 45. So 45 is which of the following statement is not applicable to chemist option? It is slow, correct. Irreversible, correct. It is highly specific is also correct. But it is independent of temperature is wrong, because what will happen? It will increase and then decrease. There is dependence of temperature, x by m versus temperature. This is the graph, increases and then decreases. So the answer should be option C. Moving to 46. Already we have completed this, option D. So 46 is the same repetition of the question, so no need to go for this. Moving to 47, the diameter of colloidal particles ranges from, colloidal particles diameter is 1 nanometer to 100 nanometers is done. 1 nanometer is 10 power minus 9 meter, 100 nanometers becomes 10 power minus 7 meters. Range between these two is in the option A, so the answer should be option A. Next, 48. Lyophilic colloids are stable due to excessive solvation. Due to excessive solvation of dispersion medium. So surrounding of dispersion medium is responsible, excessive solvation. So it is not related to charge, it is not related to size, it is not related to size. So it is only because of dispersion medium. This is correct. So where you have dispersion medium influence, that is the reason for the stability. So the answer should be option D. So the answer is option D. Coming to 49. Which of the following characteristic is not correct for physical adsorption? For physical adsorption, which is not correct, and the answer for this physical adsorption, it is reversible is correct. Increases with increase in temperature is wrong, because it is x by m is inversely proportional to temperature. It is spontaneous is correct. Enthalpy and entropy are negative is correct. So the only option which is wrong over here, the question is not correct. So we should see the question carefully. So the answer should be option B. So the answer is option B. Moving to the 50, the last question which we are going to take now. The dispersed phase on colloidal iron hydroxide and colloidal gold positively and negatively charged respectively. Which of the following is not correct? Not correct is the question. And now the answer for this particular one. So the options, coagulation in both, we are talking about not correct. So coagulation in both soles can be brought out by electroforces. Yes. Mixing has no effect. When positive is mixing with negative, it leads to coagulation. It leads to coagulation. Do we say no effect? No, it is wrong. Sodium sulfate solution coagulates in both. Yes, because it has positive, it also has negative. Yes. Magnesium coagulates, chlorides coagulates the gold more rather than iron hydroxide. That is correct, because +2 and -1 is there. This will have Hardy-Skulls rule. This will affect more in coagulation. So these are correct. The only option which is wrong is option B. So that is our answer. Option B is the wrong option in this particular one. So this is our questions for today on electrochemistry, solutions and surface chemistry. Hope everyone have clear, concepts are clear. Just go to the synopsis again, brush up your concepts fastly, use it. You can easily answer any question given to you. So this is our session. Thank you. We'll meet in the next session of online classes.